Hi everyone, this is Mr. Richmond, and for this video we're going to be taking a look at the rock cycle simulation that I've posted on your P-Learning page. When you have some time, I'd recommend going into the simulation, clicking on some of these icons, and also taking a quiz that's available on this website to increase your understanding of the rock cycle. I would bet that a lot of you have some background information on the rock cycle already. You may even know that we can characterize these rocks into three main categories, such as sedimentary, metamorphic, and igneous rock. An important thing for you to understand about the rock cycle is that depending on what process or what conditions that rock is exposed to, we can have one rock turn into the either two remaining rocks or even back into itself. So let's have a look at some of these processes that a rock is going to undergo, such as cooling, melting, heat and pressure, weathering and erosion, and finally compacting and cementing. Another important thing for you to keep in mind is that when we have one rock change into another, this does not happen overnight. It can take hundreds of thousands, if not millions of years for this process to occur. So let's have a look at some examples here. I'm not going to go through every single scenario, but let's just follow a sedimentary rock into a metamorphic. In order for a metamorphic rock to occur, it's usually going to be exposed to heat and pressure. So in order for that to occur, it looks like we have sedimentary rock that's going to be underneath the Earth's surface. It's exposed to heat and pressure. It's going to develop these layers and bands that are often going to be characteristics of what we can identify as a metamorphic rock. So that's the key term for metamorphic, is heat and pressure. That's a process that you're going to be looking for. So now let's look at how we can get from a metamorphic to an igneous rock. So we already have that metamorphic rock underneath the Earth's surface, and it's going to be exposed to even more higher temperatures than it already has, and eventually it's going to melt and become magma. That's probably a term that you recognize. You know the term magma and lava already. So now that we have magma, we have this liquid form of a rock. Eventually it's going to cool through the process of a volcanic eruption. And this magma or lava can cool in two different ways. It can either happen on the inside of the Earth's surface, on the inside of this volcano, which we would call intrusive. Think of that prefix in, intrusive igneous rock. That cooling is going to happen a lot slower compared to our extrusive igneous rock, which would be on the outside of the volcano. So intrusive igneous rock is going to be on the inside, extrusive on the outside. You could probably guess which one would have a hotter temperature or which one would even have a cooler temperature, which one would allow for this cooling to occur at a slower or a quicker rate. So you probably guessed that temperature is a lot higher on the inside of our volcano, which means that the cooling is going to take a lot longer than compared to our extrusive igneous rock. So some characteristics of extrusive igneous rock: because it cools so much faster than intrusive, it's going to look glossy and smooth. You might have seen the obsidian rock before, and it's characterized by this nice glossy texture. An intrusive igneous rock, however, is going to take a lot longer because the temperature, again, is a lot hotter, and that increase in time is going to allow for these large crystals to form. So that's going to be a characteristic of intrusive igneous rock, is these large crystals. For extrusive igneous rock, we're going to be looking at a nice glossy texture. Finally, we're going to have an igneous rock that's going to be exposed to weathering and erosion. So for example, if we now have rocks that are on the side of a mountain or a volcano, in this case, are going to be exposed to weathering and erosion, and these rocks are going to eventually break down, forming what we call sediment. And again, depending on what that sediment is now exposed to, we have some compacting and cementation. You think of that word cement, it's compacting together. And often we have characteristics of sedimentary rock looking like they have a bunch of little different rocks compacted together. Sometimes even you'll see evidence of fossil life in these sedimentary rocks. Walking around on the Earth's surface around here in the New England area, this is the most common type of rock that we'll see. But keep in mind that just because it's a sedimentary rock right now, again, depending on what is exposed to, it can always turn into either a metamorphic or an igneous rock. And this process is ongoing. I hope this video helped your understanding with the rock cycle, and good luck with your future assignments.